A ticking clock, a desperate plea, a life hanging in the balance, waiting for a donor organ. This is the grim reality for thousands of people worldwide. But what if I told you there's a technology on the horizon that could eliminate this agonizing wait? What if we could simply print a new heart, kidney, or liver on demand? This is the promise of bioprinting. Welcome to Mindscope, where we explore the frontiers of science and technology. Today, we're diving into the fascinating world of bioprinting. Bioprinting is a revolutionary technology that combines 3D printing with the science of biology. It involves using specialized printers to deposit living cells and biomaterials layer by layer. This process creates functional, three-dimensional tissues and organs. The core principle of bioprinting lies in the creation of bioinks. Bioinks are suspensions of living cells mixed with a biocompatible material. This material acts as a scaffold, providing structural support and nutrients for the cells. Common bioink materials include hydrogels, which are water-based polymers that mimic the natural environment of cells. The selection of the right bioink is crucial for the success of bioprinting. It must be non-toxic, biodegradable, and promote cell adhesion and proliferation. The bioprinting process itself involves several key steps. First, a 3D model of the desired tissue or organ is created using medical imaging techniques like MRI or CT scans. This model serves as a blueprint for the bioprinter. Next, the bioprinter precisely deposits the bioink layer by layer, following the digital blueprint. Different printing techniques exist, including extrusion-based printing, inkjet printing, and laser-assisted printing. Each technique has its own advantages and disadvantages in terms of speed, resolution, and cell viability. After printing, the tissue construct is often placed in a bioreactor. A bioreactor is a controlled environment that provides the optimal conditions for cell growth and tissue maturation. The potential applications of bioprinting are vast and transformative. One of the most promising areas is regenerative medicine. Bioprinting can be used to create skin grafts for burn victims, cartilage for joint repair, and bone for fracture healing. Another exciting application is drug discovery. Bioprinted tissues can be used to test the efficacy and toxicity of new drugs in a more realistic and human-relevant environment than traditional cell cultures. This can accelerate the drug development process and reduce the reliance on animal testing. Furthermore, bioprinting holds the potential to revolutionize organ transplantation. Imagine a future where patients can receive custom-made organs grown from their own cells, eliminating the risk of rejection and the need for immunosuppressant drugs. Despite its immense potential, bioprinting faces significant challenges. Creating complex, functional organs with intricate vascular networks remains a major hurdle. Vascularization, the formation of blood vessels, is essential for delivering oxygen and nutrients to cells within the tissue. Another challenge is ensuring the long-term survival and functionality of bioprinted tissues after implantation. The immune system can attack and reject foreign tissues, even if they are derived from the patient's own cells. Furthermore, scaling up bioprinting to produce organs on a large scale is a complex engineering and manufacturing challenge. Standardization of bioprinting protocols and materials is also needed to ensure reproducibility and reliability. The ethical implications of bioprinting are also important to consider. Who will have access to this technology? Will it be available to everyone or only to the wealthy? What are the potential risks of creating artificial organs? Could they be used for enhancement purposes rather than just for medical treatment? These are just some of the ethical questions that need to be addressed as bioprinting technology advances. A thoughtful and inclusive dialogue is crucial to ensure that bioprinting is used responsibly and ethically. Bioprinting is a rapidly evolving field with the potential to revolutionize medicine. While significant challenges remain, the progress made in recent years is remarkable. From skin grafts to drug testing to the prospect of printed organs, bioprinting offers a glimpse into a future where disease and injury can be treated with unprecedented precision and effectiveness. The journey to fully realized bioprinted organs is a long one. But the potential rewards are immeasurable: healthier lives, longer lifespans, and a future free from the agonizing wait for life-saving transplants. Thank you for joining us on Mindscope. Join us next time as we explore another fascinating frontier of science.